Here we're going to look at topic 87, example 2, identify the least common multiple of polynomials. So this is going to be our preparation for finding common denominators when we get to adding and subtracting rational expressions with unlike denominators. So what we're going to need to do is find a least common multiple, which will again in turn become our common denominator when we are adding or subtracting rational expressions. So first thing you're going to have to do is factor. And here we have x plus 2 squared, and I have x squared plus 5x plus 6. So x plus 2 squared can be rewritten as x plus 2 times x plus 2. And then for x squared plus 5x plus 6, I want to use the factor sum method. So I need to find factors of 6 that have a sum of 5. You should be getting pretty used to this method by now. 1 and 6 gives us 7, 2 and 3 is 5. So my factors would be x plus 2, x plus 3. Right. So by this point, you should be pretty used to the factor sum method, the greatest common factor method, AC method, and difference of squares. So you want to be very familiar with those methods. All right. Now, once all of your expressions have been factored, the next thing you're going to look at is listing kind of the parts of those expressions. So when we're dealing with our LCM, our least common multiple, you're going to look at each part of each factored form of what will turn out to be our denominators later on. But right now we're just looking at specific polynomials. So x plus 2 squared was x plus 2 and x plus 2. So I'm going to write each of those pieces down. So I'm going to take this x plus 2. And your LCM is going to be made up of all of the parts of each individual part. And I'm not phrasing that very well, but you'll see what happens. So my first two pieces or terms or expressions are the x plus 2 that I've highlighted in blue and the one I've highlighted in orange. Now once I have all of them listed for the first, let's say polynomial, the second polynomial I'm going to do the same thing. However, this x plus 2 here, I've already accounted for because I have an x plus 2 listed below. Now they only share one, so that's why I did need to list that second one that's highlighted in orange. And now I can list that x plus 3. Just make sure that each of the terms, or let's say groupings, from your two polynomials in this case are listed, and they are, right? We have the x plus 2, so this is, we can check this off. We have the x plus 2 in orange, and we have the x plus 3 in red. Okay, so each of those has been listed, so we have everything there. This will take a little getting used to, especially when you start mixing in fractions. It does get a little cluttered and a little bit messy, but you'll start to figure this out without too much difficulty. Part B, we have 3 polynomials. All right, so 3 expressions here. So again, we're going to start by factoring them. X cubed minus 9x. I'm going to factor an x, they have a common factor. I'm left with x squared minus 9, which you should recognize as the difference of 2 squares. So that can be factored further into x plus 3 and x minus 3. Then x squared minus 2x minus 15. I need to use my factor sum chart. So factors of negative 15 that have a sum of negative 2. So factors of 15, we have 1 and 15, 3 and 5. That's a 3. Let's fix that. One of these is going to need to be negative. So let's make the larger numbers negative. The second group works. So this would factor into x plus 3 times x minus 5. And then finally, I have x squared minus 5x. Common factor is x, and I'm left with x minus 5. Okay, so each of those pieces has now been factored. This is what you would do if you were dealing with fractions, which again, I keep mentioning it, but in the next example, the next video, we're going to be adding fractions or rational expressions that have unlike denominators. So we'll need to match them up. All right, so our LCM. Again, you're going to take pieces from everything. So my first expression, I have an x, so I'm going to bring that x down. going to be lots of highlighting here. Then I have an x plus 3, so I want to bring that expression down as well. And finally, x minus 3 from that first expression. Wrong color. All right, so everything's been taken from that first expression, the first polynomial. So I look at my second expression. That x plus 3, that first term here, I already have an x plus 3, so I don't need to bring it down. I'm just going to mark it with the same color. X minus 5, that is new, so I'm going to need to bring that down and highlight that appropriately. And then in my final expression, I have an x, which I've already accounted for, so I don't need to bring it down again. And I have another x minus 5, which again, I already have. So what we're looking for is that each term in the factor form are all accounted for, which they are. So I have my LCM of x times x plus 3 times x minus 3 times x minus 5. All right. It will take a little bit of getting used to. When you do the triad problems, 5 and 6 are a little bit more challenging. Maybe start with 7 and 8. They're a little bit easier and more straightforward, but you do want to make sure that you can also obviously do numbers 5 and 6. But 7 and 8 will be an easier start to practicing this on your own. The steps, the process: factor each expression, each polynomial, and then list all of the, we'll call them parts, all right, all the pieces of each polynomial. If there's an overlap, you don't need to list it a second time. These really just come down to some practice. You'll get familiar with them the more often you see this.